Jaden, I need you on the other end of this to respond to me.
I know, seriously. I'm one of two people that
Yeah, you always let me know. I know, it's really quiet. Well, that's why sometimes, I don't know why it's so quiet. All right, so let me get you started on this warm-up, and then I'll give you some time to keep working. So yesterday, over Zoom, so especially if you missed our Zoom yesterday, it would be hard to get started on this. So yesterday, we talked about 3 different angle relationships, okay? So one angle relationship is complementary angles, or angles that add up to 90. So when I see in a diagram a right angle, I should know that I can set up an equation where those angles will add up to 90. So you'll see some of these diagrams on this sheet. That's called our complementary angle. Okay, so also given an angle, I can find its complement would be the angle that combined would add up to 90. Then we have supplementary angles, which again, given an angle, I can find its supplement, which would be what would make it add up to 180. Supplementary angles create a line. So here's an example of what a diagram would look like with supplementary angles, right? This is what we did yesterday in our notes. And so I see the line, I take the angles and add them together and set them equal to 180. Okay. The last type of angle that we talked about yesterday are vertical angles. So here's an example, here's another examples. Vertical angles are across from each other, so they're not sharing any sides, and they're equal. Okay, so instead of saying this angle plus this angle equals some amount, we're saying this angle is equal to that angle and solving from there. So looking at this warm-up, let's just go through and list some cases here. What type of angle relationship do I have on the first problem? What are these? Number 3, they're vertical angles. Yeah. So what are true about vertical angles? They're equal to each other. So these are vertical, which means they're equal to each other. Okay, we'll go back to that in a minute. On number 2, what type of angle relationship is this? It's creating a line. So this is a supplementary angles. Okay, these are supplementary angles. Supplementary means it equals 180. Okay, so that's kind of like your first thought when you look at these diagrams. Don't rush to an equation. Give yourself time to think about what angle relationship do I have, okay? And then what does that mean? So then what angle relationship do I have on 3? What do I have here? They're creating a right angle, so these are complementary angles, or they add up to 90 degrees. Okay, so imagine that. The first 3 on here include all 3 cases. So now I'm going to go back to the first one. I see they're vertical. I know vertical angles are equal. My equation would be 76 equals 6x plus 4, that this angle equals this angle. That's my setup. Then we solve from there. So I subtract 4, and 6x equals 72. And I divide by 6, and what does x equal? How many times does 6 go into 72? 12.
Yeah.
Okay, so, they're vertical, that's my setup. Set them equal to each other. On example number 2, they're supplementary. If they're supplementary, then my setup would be that this first angle, 2x, plus this other angle, x minus 21, would be equal to 180. So a different setup, right? It's all based on what type of relationship do these angles have. This angle plus this angle equals 180. Now I solve. So I have 3x minus 21 equals 180. And I add 21. And 3x equals 201.
Yeah.
And I divide by 3, and that's going to give me 67, I think. Let's do a little long division. 201 divided by 3. How many times does 3 go into 20? Goes 6 times.
6
That's going to give me 18. Subtracting that 18 gives me 21. How many times does 3 go into 21? 7 times. That's how in my head I got 67. Okay, that's a good skill to have. How do I do long division? Okay. On number 3, oh hey look, those are creating a right angle. They are going to add up to 90. So angle 1, 3x plus 6, plus angle 2, 4 plus 5x equals 90. That's my setup. So that's the key, is can you write the equation? From there, it's cake. It's just algebra class, okay? It's can you set it up correctly? So now I have 3 and 5, which gives me 8 x's altogether. And I have 6 and 4, which gives me 10, equals 90.
And minus 10.
8x equals 80,
And then you divide.
and x equals 10. Okay, so it's all about knowing how to set it up. From there, I think we're all pretty strong with equation solving.
Yeah.
So I'm going to give you a few minutes to try the rest of these. It does go on to the back, and on the back, I like this too. So if you have a chance to look at this, so here's an angle. What's the complement? What's the supplement? Okay, what will make it, what adds up to 90? What adds up to 180? So I'll give you some time to work, and then we'll pick it up there, and we'll just keep going. It's going to be a lot of me talking at you today. You get the same thing on number 5? You get 8x equals 80?
Yeah.
And x equals 10? That's funny. Okay, so if you can pause where you're at just for a minute, I'll still let you work on the back, and just flip your page back over. So let me scroll back up to 4 here. 4, these are vertical. So your setup should have been that they are equal to each other. You feel okay about that one?
Yeah.
Okay. On 5, these are complementary, or they add up to 90. So one angle plus the other angle equals 90. Solve from there, and you get x equals 10. 6, same idea. They add up to 90. So even though it marks it over here, this is still, it's going to be 90 here and 90 here because it's creating a straight line. So whether the little box showing right angles here or over here, you're still going to add up to 90. You get x equals 34. On 7, Okay, this is a straight line. So even though there's this triangle here, this angle and this angle creating this straight line. So these angles are supplementary or add up to 180. Same thing here, straight line is created from this angle and this angle. So, oh, hey, I did it wrong. Hey, look at that. So I got 108 plus 2x plus 18. I was in the zone. Just filling things in. Okay, so then you get 2x plus 126 equals 180, and 2x equals 54, and x equals 27. 27. Yeah, okay. Okay. Sorry about that one. Okay. So now if you're still working on the back, you can keep working. I'm just gonna flip it over. So I wanted to make sure we went over those. We feel okay about those? Okay. And so I'll let you keep working, and I'm going to make decisions and set up equations correctly this time. I'll write up here too what I'm doing. Yeah. Yep. Okay. So on the back, we have 4 more diagrams. The first diagram shows vertical angles, so they're equal to each other. And we solve, get x equals 17. Second diagram, complementary angles, so they're equal to 90. X equals 22. Supplementary angles on number 11, so angle 1 plus angle 2 equals 180. Solve and you get 27. Again, the way we do this division when it's a little trickier, so 162 divided by 6, I say to myself, how many times does 6 go into 16, which is twice? That's 12, gives me 42, goes in 7 times. Okay, so since we aren't having calculators right now, okay, let's try to have that scale down. How do I divide into a larger number? On 12, these are 90-degree angles. So angle 1 plus angle 2 equals 90. Solving, you get x equals 19. Okay, our last little section here is different. So it gives me an angle, and I'm gonna find the measure of the complement and the measure of the supplement. So if my original angle is 57, then what would the complement to that angle be? 23. And no, 33, you're right, I'm doing it wrong. 33, I was going to 180 instead of 90, like the 20 and the 3. So 33, why is that my complement? Yeah, because what equals 90? 57 plus 33 is going to equal 90, exactly. So same question when I do 57 in the supplement, I'm saying what number plus 57 would add up to 180? 123. Yeah. If my angle is 24, then what would the complement to my angle be? 66. Okay, because 66 plus 24 would add up to 90. If my angle is 24, what would the supplement be?
156.
Okay, get this idea? What about 33? What's the complement?
57.
57. And what would the supplement be?
147.
And if my angle is 82, the complement is
9,
8.
8.
And my supplement would be 98. Okay. All right, so I want to make sure we have time to totally talk about that unit review, which is a bulky document. So you had homework 14. I asked you to complete evens for today. Okay, so we're going to go through the evens, but we'll also do the odds, which means all you'll have between tonight and tomorrow will be to prepare yourself for the unit test that we're going to take tomorrow. Okay, so that means that you will be home Monday and the other group will be taking the unit test. So you don't have to zoom in on Monday because they'll just be doing the test. We won't be doing new things, okay? Does that make sense? No, there won't be anything on there on Monday, okay? So one, we haven't done one yet. I'm just gonna kind of go through the diagram. So certainly you'll be asked to do this on your test. This just asks us to draw a line through C and D. So here's my line and it has points C and D. It could have other points on it, by the way, too, but as long as C and D are on that line, we're good. 2 says draw a visual of segment addition and include the equation. So we haven't really been asked that question before. That just means have a segment that has some parts inside of it. So I just drew a segment A, B, and C. So here's a visual for segment addition where this would be the equation for segment addition. Where I'm saying this part AB plus this part BC equals the whole segment AC. Okay, so I'm just kind of giving an example of what segment addition looks like. Number 3, a line segment from R to T. There's my line segment from R to T. Does anyone need a new homework document? Because I probably have extras. You want one?
Yeah. Sorry, guys.
Okay, I have extras. These are- It's the very back of this. Did I get you too? It seemed awfully quick. Anyone else want a new? Okay. Number 4, A is the midpoint of segment BG. So here's A on segment BG and it's the midpoint. So I'm showing that it's the midpoint by marking these as the same. It's in the middle. 5 says a line segment from E to F. So here's my line segment from E to F is bisected by line M. So bisected means cut in half. Okay, so that's important. So bisected, I'm marking that it's equal on both sides. Okay, now let's do this together. So then in the following diagram, answer these questions. So what is the intersection of plane P and line BN? So here's line BN. Here's plane P. Where do they meet? Point B, yeah, right here. It's going through the plane and coming out the other side. And remember, when we write a point in geometry, we need to not just write B, but write point B. What points are collinear with point B? So this is a little bit of a tricky question because B is on more than one line. So points that are collinear with point B, well, F and M are collinear on this line, but N is also collinear with point B on a different line. Okay, so we should have all of those there. Okay, any of these points we could say are collinear with B. They are on the same line as B. Name all points that are coplanar to F. So here's F. Coplanar means on the same plane. Here's my plane. The only point not on the plane is M. So basically I'm going to list every point and not this one. All the other points are coplanar to F. So point B, point M, and point O. Notice that like this L is labeling a line. That's not a point, so it's not a coplanar point. And P is a plane. It's labeling the plane. It's not a point either. What point is not coplanar with point M? So here's point M. Here's the plane it's on. Here's the point that's not on that plane, point M. How many possible ways can you label line FB? So here's line FB. I'm going to redraw line FB. So it goes F, B, and M. All the ways that I can label this. So we have FB. We could also call it BF. What's another way? Yep, so yeah, you're right. It's called, I could call it line L. What somebody said on one of the other ones. MB, sure. So I could call that line MB, or I could call it line BM. What else? FM or MF. Okay, so I can label that with any 2 points that are on that line. I never use more than 2 points when I'm labeling a line. So both ways, both directions. So for each kind of 2 pairs, I have 2 options. And then, yeah, if it has a little cursive letter with it, I can also use that to label that line. I could call it line L. Good. Flip this page. So this is like some algebra linked to some geometry ideas. It says that J is the midpoint of CT. So if it's the midpoint, what does that mean? Yeah, so I have to know what a midpoint means, which means it's right in the middle, which means this length and this length are the same. So maybe I label that. And then it tells me CJ, so from C to J is 9x plus 1. And from J to T is 2x plus 15. So it tells me some info, which I'm then labeling on here, okay? And if they're equal, then that's how I know how to set up my equation is, okay, it's the midpoint, so that must mean that this length, CJ, that 9x plus 1, is equal to this length, JT, 2x plus 15. Okay, that they must be equal, and then that's how I can solve for x. So that would give me, subtract 2x from both sides would give me 7x plus 1 equals 15. 7x equals 14. And x equals 2. Now notice it asks for more than that, okay? So it also then asks us to decide, okay, well, what would CJ equal? Well, I can substitute in 2 for x. Here's CJ from C to J, And if I plug 2 in, then I have 9 times 2, which is 18, plus 1 is 19.
Isn't the other one also?
Well, so you gotta be careful. So this asks actually for CT. So yes, totally, the other half is 19, but it asks me for CT. So now I know that this is 19 and this would also be 19 because they're the same. So then this question wants you to put that together and say, well, if I have 19 and 19, the whole segment must have a length of 38. Yeah, this must be 38. Okay, so that's 11. On 12, this is what our warm-up was. So what type of angle relationship is this? Supplementary, or it's creating this line. So, and again, this one you should have done for homework. So I'm going to kind of just talk us through to the answer. So I can see that they're supplementary. That means they add up to 180. And then solving for x, again, this was a homework one, so we should already have an answer here. I get 4x equals 168 and x equals 42. Now that I know what x is, oh, this was one I had an issue with because they didn't have the labels. It's supposed to be like this, A, B, C, and then D here. So then it asks for the measure of A, B, C, which you wouldn't have been able to do for homework last night because it was not labeled, but that's this angle here from A to B to C. So if I know x is 42, I can plug that in, which gives me 126 plus 2, or 128 degrees. And CBD, angle CBD, if I follow those letters, C, B, and D, that would be the other angle. And so if I plugged in 42, that's just x plus 10. So if I plugged in 42, this would be 52. Yeah, Joe? Yeah. Good. And then if it had asked me to find the whole angle, well, I already knew. So the other thing, I already knew this whole thing was 180. So if this was more complicated, I could have also just subtracted 128 from 180 to get there. Okay. And this should add up to 180, which it does. This is also a little bit about angle relationships, and it's also about you being able to determine what angle we're talking about. So APC, this angle here, there's a few different ways I could label the angle that it's equal to, but what angle would it be equal to? DPB, yeah, sure. So vertical angles would be equal. These angles would add up to 180. So that's what it's asking you to look for. This angle would be equal to this angle. And because there's 2 points on here, there's a few different ways your angle could be labeled, but we'll call it angle DPB. Okay, then it says DPB, which is here, plus BPC, which is here, so the 2 angles I have highlighted in green, equal what? There's 2 answers I would accept on a test. So one thing is you could say that those 2 angles equal 180, yeah, because they're a straight angle. Or if you give me an angle addition, that's okay too. So if you said that DPB plus BPC equals angle DP, what did they use? DPC, like if you gave me what those 2 parts added up to as a whole angle, I'd take that too. As long as it's a true statement that you're giving me, DPC. Okay, or DPC. APF and FPB are, I had written adjacent on the key, but that was from former years. I would say probably we should say those are supplementary. Okay, that's here, APF and FPB. Okay, these are supplementary angles. And name the angle pairs that are congruent. Well, we already have one listed here. So we know angle APC is congruent to angle DPB, these angles. But when I have vertical angles, I always have two sets. So if these are equal, these are also equal, the other pair of vertical angles. Okay, so I could also say that angle APD is congruent to angle BPC. Okay, so these angles are also congruent. And if you wanted to make your life easier, by the way, you could have, say it's a test, if this is confusing you, do this. 1, 2, 3, 4. I just simplified the diagram. That's fine. So I could have also said angle 4 is congruent to angle 2, angle 1 is congruent to angle 3. Okay, see how I can use numbers to just make it a little clearer for myself? That's fine. Okay, so if you went around and labeled them with numbers and then use that, that's fine. Okay. So for the next page, again, because you did homework, I'm going to kind of show you the answers to the, you did evens, right? To the evens, but we'll do the odds. So next page is segment and angle addition. Part plus part equals whole. It's all about being able to set up the equation. So this part plus this part, or 2x plus 30 plus 5, part 1 plus part 2 equals the whole segment. Or 2x plus 35 equals x plus 24. Subtract x. X plus 35 equals 24. And x equals negative 11. Okay, that's 17. You should have done 18 for homework. 18, again, part plus part plus part equals whole. Gives you x equals 10. Once we get to angle addition, it's a little trickier because we have to label. So on 19, RST. Okay, so looking at where RST goes, RST is the whole angle, 152 plus 2x. BST, BST. That's this piece here. That is 58. And last, RSB would be the other part is x plus 94. Once I have my angles labeled, now it's the same as segment addition, where I'm saying one piece here plus another piece here. So this plus this is going to equal my whole angle. There's my setup. Or x plus 152, adding these 58 and 94 together, equals 152 plus 2x. And then it gets kind of weird. So if I subtract x, 152 equals 152 plus x. But when I subtract the 152, I just get x equals 0 here. Okay, which is kind of weird, but if I were to plug it in, it would all work. It would be one part plus another part would add up to that whole angle. And again, 20 you should have done last night. So I'm just going to show you 20, but same idea. So you have to have it labeled correctly for it to work out. And then part plus part equals whole, and you get x equals 7. Okay, so that should be like I feel like that's a little bit of a gift on the test. I feel like we've been doing pretty well with that. So make sure we're solid on setting it up, and then it should be a pretty good section. I also think the next piece will be a pretty good section. So if you flip this page over, it switches into if-then statements. So these are on our test as well. If an angle is 150 degrees, then it is an obtuse angle. What is the hypothesis there? Yeah, I don't need the if, I'm just gonna write an angle is 150 degrees. The conclusion would be
It is an obtuse angle.
it is an obtuse angle. So there's my statement, hypothesis and conclusion. The converse statement is switching the hypothesis and conclusion around. So what would the converse read as?
If it is an obtuse angle, then it is
150, yeah. And sometimes you gotta play with the wording a little bit for it to read a little smoother. So I'm gonna move the angle piece around. So I'm gonna say, if an angle is an obtuse angle, then it is 150. So I'm just kind of wordsmithing it a little bit, but I'm still flipping the concept of hypothesis and conclusion. So if an angle is an obtuse angle, then it is 150 degrees. Is that converse true or false?
False.
False. It could be, but not necessarily. 150. Yeah. If a converse is false, give a counterexample. If the converse is true, rate it as a biconditional. So since we're saying it's false, I like to just go as close. I don't know. I always go 151. You know, I go 1 degree higher or whatever. But a counterexample is a specific example. I can't just say any angle above 90 degrees is obtuse. That's like a thought, but it's not a counterexample, a specific example. So I'm just going to say 151 degree angle is obtuse. Okay? Same idea on 24. So if x equals 25, then the square root of x equals 5. What's the hypothesis? Yeah, x equals 25. And the conclusion would be? Yep. And if I write the converse of that, and I flip those around, it would be if the square root of x equals 5, then x equals 25. Is it still true? Still true. And so since it's true, we're writing a biconditional if and only if. So, and it doesn't matter with a biconditional which piece here. So I have two pieces. Here it's written one way, here the pieces are flipped. It doesn't matter which way I write it. I can take either piece and put it on either end. So I'm just going to put square root of x equals 5 here. And watch this. X equals 25 here. And I'm going to connect them with my special magical biconditional words of if and only if. Okay, the square root of x equals 5. If and only if x equals 25. Okay, good. Given the information, make a conclusion and justify each. So this is the first time we've really seen it this way. This is really linking to proofs. So what this is really doing is saying if I'm given this in a proof, okay, if I were doing a proof instead, and I was given this, if that's my given, if you want to think about it this way, that's what these questions are asking. What would the next statement be? X equals 13. That's my conclusion. So if I know this, my conclusion is that x equals 13. And obviously I don't need to write this little mini proof out. I'm just kind of showing you what it's asking for. And the reason we can say x equals 13 is because we just subtracted 7. So subtraction. That is what my justification is. So really, conclusion is like in our proof, the statement we make. And justification is the reason we can make that statement. So it's taking this and writing it a little differently. If this is true, then this is, that's why. And if this is true, that's why. If it gives you something like this or even like this, where it's a visual thing it's describing, draw the visual. I'm gonna say it again, draw the visual, okay? Don't try to go off of just the words. So this says I have angle ABC. So first I'm gonna draw an angle ABC. It is being bisected, which means cut in half, so it should be look like it's about halfway, by ray BX, which means I have a line in the middle that goes from B to X, okay? That's the visual, okay? And so if I'm given that, and it's bisected, which means these angles are the same, there are two answers that I would take here. So I'm going to write one here, and then I'll write the other that I would accept on the test here, okay? Because depending on the proof, there may be different things you want to write. Because it says bisect, I would think a lot of people would think about the fact that bisect means equal angles. So one thing that I could write, one conclusion that I can make, is that the measure of angle ABX is the same as the measure of angle CBX, because that is the definition of bisect. We haven't lived a whole lot in bisect midpoint land in terms of using that, but if this is true, this is probably what we want to write, definition of bisect. Yes, Michaela?
Did you also say that it's congruent?
Yeah, that's fine. Now, we haven't lived a ton here. And the other thing from that visual that you may see, and it's been a look for the whole time, is that I could say that angle ABX plus angle XBC equals angle ABC. Okay, so one thing you may observe is that, hey, that breaks it into two parts out of the whole angle. And we have used that a lot. And part plus part equals whole. The reason I can say that is angle addition. I would take either. If you gave me either of those on your test, that's lovely. As long as from that you can say something about it and why you can say that something, I'm good, okay? Same thing on 29. There's two kind of things I would accept here. So B is the midpoint of segment XY. Again, if it's describing a visual, draw the visual. So I have segment XY, and B is the midpoint. Midpoint meaning it's in the middle, or that it's the same amount on both sides, it's in the middle. So again, one thing that I could write is about the midpoint. So I could say, well, if it's the midpoint, then I marked it because I know that XB then must equal BY. Because that is the definition of midpoint. Okay, one acceptable response. But I also have a segment here. And so another thing that I could use from this diagram is I could say that XB plus BY equals XY, which is just segment addition. Okay. Nervous we're going to run out of time.
I don't know.
Need water. Too much talking.
I already have more. I just don't know if I can drink it or not.
Yeah, you can do like a quick drink. It's hard though, it's not comfortable. All right, let's talk about proofs, and then we'll look at that back page, which we've already kind of done. It was our warm-up today, so if we don't finish all of the back page, I feel okay. Our algebra proof should be a gift. We love algebra proofs. Okay, make sure you fill that out completely and take your time on your algebra proof. Yeah, Gemma.
Do you put the given on number 1 and the prove on number 4?
Yes, but on this one, there's actually an error and there's only 3 steps, but yes. So if I were to fill this in, I could absolutely go ahead, and I know that this should be here, and I know that x plus 8 should be here. So if you want to fill those in first, yeah, absolutely. This is given. From here, what would I do? What's my next statement?
You add 7.
I would add 7, and that would tell me that 4x equals 32. All I did there was addition. And if 4x equals 32, my next statement would be that x equals 8. There's my proof. And the reason I can say x equals 8 is because division. Notice there's not a lot of proofs in this review. So like your test isn't all proofs. And sometimes I feel like kids get so focused on them that you forget all the gifts that are in the test, right? Like the algebra proof should be a gift. I think segment and angle addition, those equations we've been doing for a while, those should not be super challenging. Even the angle stuff we did today. Okay, so study those things. Don't forget to study and be prepared for those little pieces too, because those are going to be worth more points than just a couple of the proofs at the end. Proofs are worth a lot of points. Okay, so you don't want to like leave them blank, because here, like I would see 6 points here. Okay, 1 for each of these and 1 for each of these. So certainly another, on top of that, the other mistake is don't leave your proofs blank just because you're scared of them. Okay, do whatever you can, get however many points you can out of your proof, and then move on. Okay, and focus on the rest of the test. So this one has a little fill in the blank. So again, like points wise, maybe this would probably be each worth a couple of points. So maybe again, this one's worth 6 total, where it's like 1, 1, and 2 here, 2 here. Okay, so fill in what you can. Like if you can get like this and this, that's great. And then if you have something here that I can give you partial credit on, okay, don't be afraid of it. Do what you think. We're learning how to write proofs, so just do the best you can. So here we have a given, and it's separated it. So you can see that the second step should just be the next given. That's like a gift if that's on your test. So what's my second given? BC equals EF. On my geometry proofs, I want to label my givens too. So I know that AB is congruent to DE, and I know that BC is congruent to EF. Okay? Those are my givens. What happened here? Kind of feels like substitution, but not quite. We took this, and because it's the same amount, we added it on both sides of the equation. So this is addition, just addition, where I'm taking the same amount and I'm adding it to both sides of the equation. So that would, I feel like this one right here would be the trickiest piece to get on this proof. Because then the next one says segment addition. So we know what segment addition looks like, right? And we have the visual. What would the segment addition be for this visual? There'd be 2 equations. What would one of them be? What would my equation be here? Yeah, okay, so it's telling me I want to write out segment addition here. So I'm going to have AB plus BC equals AC. And my other equation, also on step 4, would be
plus EF equals
yeah. Okay, it's telling me segment addition. I know what those equations look like. Now, then the last thing it does, and so what's happening is it's taking this equation and saying, well, AB plus BC equals AC, so I can put AC in its place right here. I could change this and just write it as AC. And this is equal to DF, so I can change that and just write it as DF. What is that called when I change what's there and put something else in? Substitution. So let's talk about the difference between what happened on 3 and what happened on 5. Did you hear what I just said? I took something and I replaced it with something else. I substituted it. What happened on 3 is I didn't replace anything. I added something in to both sides. Okay, it's you gotta be careful with those differences, but it is different. Okay, so there's our proofs. That page goes back to our angle stuff. You should totally anticipate a table with complements and supplements. We just did this. So I can go through it real quick. What's our complement? That means our angle and this number should add up to 58 adds up to 90, yeah. And here's my angle. The supplement in this angle would add up, I would have a supplement of 148. Going to add up to 180. Now the table is a little bit tricky because it doesn't always just give me the angle and ask for the 2. So on the next one, it gives me my complement. So if my complement's 61, then my original angle is 29. Just be careful, like you're finding the supplement of your original angle. So don't find the supplement of your complement, okay? So the way this table is set up, so if I have a complement, I gotta find my angle first. Now, what's the supplement to my angle? Okay, does that make sense though, what you need to do there? What did you say?
119.
Are you doing it with this? So what, okay, so now I know what you're doing. So what I'm saying is don't use this to find your supplement. So you know the complement, you need to find your angle. This is saying what's the supplement of your angle? 151. Yeah, you see how that can be tricky? So this column and this column is always related to this original angle. Okay, they never are talking to each other. Okay, so from the complement, I can find my angle. Now, with this angle, what's the supplement to the original angle? Okay, 151. Same idea on the next one. If this is the supplement, then my original angle would be
57.
And now I use the original angle and find the complement to that angle, which would be
33.
And then this one gives me my angle, so the complement to 46 would be, and the supplement would be,
34.
okay? So just be really careful with that table. Both the complement and the supplement, you're comparing it to these numbers. Okay? And then this is exactly what we did this morning. I'm gonna run out of time. So I think what I'll do is I'm gonna show you answers if you wanna write them down. They're also online. But let's just talk through it. So these are vertical, which means I can set them equal. These are complementary, so I know that they add up to 90. Okay, so I get 3 and 12. So if you just want to note the final answer so you can check yourself. These are creating a line, so I know that they equal 180, and that's what I set up my equation as. This one's a little tricky. It's vertical and then vertical again. Okay, so there's 2 equations there. There's an equation with y, and there's an equation with x, but they're both vertical angles. Vertical, which means they're equal to each other. So this is equal to that, and that's equal to this. My bottom equations, so I get 16 for x and 10 for y on that one. This is, again, equal to 90 here. And then my last one is equal to 180. Okay. How do we feel overall?
Notice how I have